Welcome to This Explainer. We're jumping right into an epic, frankly messy, and totally fascinating scientific journey. We're talking about the trials, the agonizing errors, and some pretty gross experiments that literally built the foundation of the modern world.
Picture this. There's an invisible war raging right inside your kitchen this very second. Every piece of fruit, every open bottle of wine, that gallon of milk, they're all battlegrounds. And for thousands of years, humanity was totally oblivious to this. We just watched helplessly as our food spoiled and diseases spread. Today, we're exploring how relentless experimentation, a process that is, by its very nature, fraught with failure and dead ends, finally allowed us to understand and start winning that war.
Act 1. The prevailing myth. So, for centuries, the accepted scientific dogma was this idea called spontaneous generation. People literally believed that life, like maggots, mold, or bacteria, just magically poofed into existence from dead matter. Wild, right? But then Louis Pasteur comes along with a radical, highly controversial counter-idea, germ theory. He suggested that invisible microorganisms were just floating around in the air, landing on organic material and causing all that decay. But, to defeat deeply entrenched dogma, you need absolutely unassailable proof.
And to get that proof, Pasteur designed a brilliantly elegant experiment using a swan-necked flask. He boiled some meat broth to kill absolutely everything inside it. The real genius, though, was in the curve of the glass neck. It let air flow in, but gravity trapped all the airborne dust and microbes right in the bend before they could ever reach the broth. As long as you didn't tip the flask over, that broth stayed totally sterile, indefinitely. Boom. He proved that microbes were coming from the air, not just spontaneously generating out of the broth itself.
Act 2. The messy 1862 breakthrough. Now, this next major leap forward required a pretty unlikely collaboration. Pasteur teamed up with a renowned physiologist named Claude Bernard. And the funny thing is, they didn't even agree. Bernard was convinced fermentation was strictly a physico-chemical process, while Pasteur insisted it required living organisms. But instead of just arguing in circles, they brought their distinct areas of expertise together. They understood that true innovation means debating ideas and testing them rigorously, even when it gets messy. Which brings us to April of 1862 and the, frankly, gross test subjects of their most famous joint experiment. They wanted to see if heat could control these airborne microbes without actually destroying the liquid itself. So they chose two highly putrefiable substances, dog blood and dog urine. Yeah. They sealed these liquids in glass vials and heated them to a gentle 30 degrees Celsius, that's about 86 degrees Fahrenheit, for 6 full weeks. Talk about a testament to the absolute messiness and resilience you need in scientific trials. After 6 weeks baking in that heated stove, they opened those sealed vials right in front of the French Academy of Sciences on April 20th, 1862. And the number of putrefied samples? 0. None. The blood and urine hadn't decayed at all. They had completely proven that gentle, sustained heat neutralizes those invisible microbes and stops spoilage without needing to aggressively boil the liquid.
Act 3. From lab to fridge.
The application of this discovery evolved pretty rapidly. It actually started back in 1856 when Pasteur was hired to figure out why beetroot alcohol kept turning sour. Then came the 1862 dog blood and urine tests we just talked about. By 1864, the French wine industry was in a massive crisis. Their exports were literally turning to vinegar on the ships. So Pasteur applied his gentle heating process, around 50 to 60 degrees Celsius, and completely saved the industry. But here's the real kicker. It wasn't until 1886 that a German chemist named Franz von Soxhlet suggested applying this exact same process to milk, a move that would go on to save millions of infant lives. And that gives us the process famously named in his honor, pasteurization. Simply put, it's applying gentle heat for a specific amount of time to eliminate or slow down microbial spoilage, all while preserving the original quality and taste of whatever you're heating. So that carton of milk sitting safely in your fridge right now, it's a direct, literal descendant of those messy, weird 19th century trials. Modern food safety, the industrial reality. Since the 1800s, this science has become incredibly precise. I mean, we're not just leaving things in an oven for 6 weeks anymore. Depending on the acidity of the food, we use very specific combinations of time and temperature. You've got that pasteurization, which is low and slow for about 30 minutes. Then there's high-temperature short time, which blasts the liquid at 72 degrees Celsius for just 15 seconds. And if you want an even longer shelf life, ultra-pasteurization hits it at 138 degrees for a mere 2 seconds. It's like a perfectly calibrated scientific dance. Now, even with over a century of proven rock-solid success, there's still a bit of controversy today, particularly when it comes to raw milk. But if we look objectively at the data from the FDA and the CDC, we can easily debunk some modern myths. Pasteurization absolutely does not cause lactose intolerance, and it does not reduce the nutritional value of the milk. What it does do is kill incredibly harmful, sometimes fatal bacteria like tuberculosis and typhoid. Before mandatory pasteurization, contaminated milk was a massive public health crisis and a leading cause of childhood mortality. Simply put, this process saves lives. The power of experimentation. This history leaves us with some profoundly important takeaways, echoing the newsletter author Papa's core philosophy about discovery. First, established dogma can only be defeated by meticulous, undeniable evidence. Second, we have to embrace the fact that scientific progress is inherently messy. It is absolutely fraught with failure before it finally succeeds. Third, as Pasteur and Bernard showed us, collaborating across entirely different disciplines is what sparks true innovation. And finally, our everyday invisible safety is built entirely on the back of these historical trial-and-error experiments. I want to share this incredible quote from Louis Pasteur himself. "Science knows no country because knowledge belongs to humanity and is the torch which illuminates the world." What a beautiful reminder of the global, timeless impact of their collaborative work. Knowledge that's built on messy experimentation transcends borders and helps all of us. Which brings us to a final, Papa-inspired thought. This process hasn't stopped. What invisible breakthroughs do you think are being tested in messy, failure-prone labs right this very second? And how many millions of lives are those specific experiments going to save tomorrow? It's definitely something to think about the next time you pour yourself a glass of milk. Thanks for exploring this explainer with me. Keep learning and stay curious.